Assalamu alaikum, sir.
Walaikum assalam wa rahmatullahi wa barakatuh. How are you, Baijid?
Alhamdulillah, sir. How are you?
Yes,
Sir,
alhamdulillah. Yes, Redwan.
I am Redon Ahmed, sir. There is no electricity in my house, and my phone has only 3% charge, sir. So I may be disconnected anytime, sir. So will you please consider my attendance for today? I will write my
Okay,
name in
Redwan.
chat box, sir.
Okay,
Okay, sir.
okay.
Assalamu alaikum, sir.
Walaikum assalam. Sanjida, how are you?
Fine, sir. How are you, sir?
Yes, alhamdulillah. So I think we can start, right? Dear student, did you get your lecture? Today's I will give some exercise, right? We are going to solve now. And what is the objective of today's class? Just after finishing this class, you will be able to know how to find the tautology and how can we determine the equivalence propositions. Okay, this is the two objective. How can you determine, I mean, which one is tautology and how can you determine equivalence propositions? Do you understand?
Yes, sir.
Yes, sir.
Okay, Sanjida Sheikh Muhammad. So 33 students are present right now. So I think we can take attendance. Uh,
Yes, sir.
Asia Tasnim Riksha. Maybe Asik, maybe we have network problem.
Yes, sir. Present, sir.
Okay, Ash. Uh,
Sir,
Asli Jaman Ashik,
I,
sir.
Assalamualaikum.
uh, ওকে এমডি আসাদুজ্জামান। আসিয়া তাসনিম রিক্তা, তাসমিম রিক্তা, তাসমিম রিক্তা প্রেজেন্ট। মেহেদি হাসান মুন্না, মেহেদি হাসান মুন্না। কে ফারহান লাবিব, ফারহান লাবিব। হাদিউজ্জামান,
Yes, sir.
সেলিম হোসাইন সোহাগ,
Yes, sir.
সাকিবুল্লাহ মিয়ান, সাকিবুল্লাহ মিয়ান। মশিউর রহমান,
Yes, sir.
আব্দুল্লাহ আল মাহাদি হাসান সোহাগ,
Yes, sir.
এমডি ইসরাফিল হুসাইন,
Present, sir.
হামিম হাসান, হামিম, হামিম হাসান। শাহাদাতুল্লাহ নাইম, শাহাদাতুল্লাহ নাইম। আনিকা বুসরা, আনিকা বুসরা। এমডি নিয়াজ মোরশেদ,
Yes, sir.
হুসাইন এমডি শাফাত,
Present, sir.
বন্নি বিশ্বাস,
Yes, sir.
এমডি নজরুল ইসলাম, নজরুল ইসলাম। রেদওয়ান আহমেদ রাতুল, শেখ মোহাম্মদ সাদিকুল ইসলাম।
Yes, sir. Present.
ওকে। ইমতিয়াজ হোসাইন রাফি,
Yes, sir.
তানজুম আক্তার,
Yes, sir.
জুলিয়ানা তনু,
Present, sir.
জুলিয়ানা, ফারজানা তানিয়া,
Yes, sir.
ইসরাত জাহান ইরা,
Present, sir.
আব্দুল খালেক,
Yes, sir.
মেহানি তমা,
Yes, sir.
অনিক পল,
Yes, sir.
অনিক পল।
Yes, sir.
ওকে। এমডি শাহিন ইকবাল,
Present, sir.
ফারজানা আক্তার হিমা,
Present, sir.
এমডি বাইজিদ, বাইজিদ
Present,
প্রেজেন্ট।
sir.
রাইদা ফাইরোজ নাসরা,
Present, sir. Present, sir.
রোমানা, রোমানা আফরোজ, রোমানা আফরোজ। লুবনা আক্তার, লুবনা আক্তার, লুবনা।
Yes, sir. Present, sir.
সাবরিনা আক্তার, ইফরাত জাহান লিমা। সাবরিনা, আর ইউ প্রেজেন্ট? সাবরিনা।
Yes, sir.
ওকে। ইফরাত জাহান লিমা, ইফরাত জাহান লিমা। আব্দুল লতিফ তালুকদার,
Yes, sir.
শান্তা চৌধুরী,
Yes, sir.
রাহাতিল মাহমুদা,
Yes, sir.
এমডি রুহুল আমিন,
Present, sir.
মশিউর রহমান 3008, খাজা মিনহাজ, খাজা মিনহাজ মিন মনিব, নাহিদা
Yes, sir.
ইসলাম,
Sir,
নাহিদা
Minhaj is
ইসলাম।
present.
হ্যাঁ, ওকে মিনাজ। নাহিদা
Yes,
ইসলাম,
sir. Yes, sir.
হুমায়ুন কবির,
Yes, sir.
খন্দকার সাকিব,
Yes, sir. Present, sir.
Okay. Then Shanjida Khan Mitu.
Yes, sir.
Archita Roy.
Yes, sir.
Archita Roy. MST Shumaya Islam Shanta.
Yes, sir.
Kazi Faria Sharmin.
Yes,
Fariha
sir.
Sharmin. Shihab
Yes,
Sharon.
sir.
Yes, sir.
MD Shihab.
Yes, sir.
Jubair.
Yes, sir.
Jubair Hussain.
Yes, sir.
And Shahin. MD Shahin Hussain.
Yes, sir.
Is anybody left?
Sir,
Sir,
Anika
as,
Bushra.
sir, Asya Tasun Rikta.
Okay, Ashia Tashia Rikta given.
Sir MD Nazrul
Thank you,
Islam.
sir.
Sir, Anika Bushra.
Mehdi Hassan Munna given.
Sir Nazrul Islam.
Sir, Anika Bushra.
Sakibullah Minna given. Wait,
Sir, Anika Bushra.
Anika Bushra given.
Sir, Romana. Okay, sir.
Sakibullah Mian given. Nazrul Islam 3062.
Yes, sir.
Nazrul.
Romana
Then
Afroz.
Romana Afroz. Romana Afroz given.
Sir, Sabrina Dansa. Sir, Lubna
Sabrina.
Akhtar.
Okay. Lubna Akhtar given. Is anybody left? Okay, dear student, tautology. Can you see the board clearly?
Yes, sir.
Yes, sir.
Tautology. What is the definition of tautology that is given in page number 4 maybe? A compound proposition that is always true, right? A compound proposition that is always true no matter what the truth value of the proposition, I mean individual proposition, does not matter. Just you need to check whether the compound proposition all are true or not. If all are true, then you can say this is a tautology. Okay. We can check. As for example, P disjunction, negation, P conjunction Q, right? We can check whether it is a tautology or not.
Yes, sir.
So what is the definition says? The definition says a compound proposition. Definitely this is a compound proposition. This is a compound proposition, not a single proposition, compound proposition. A compound proposition that is always true. Its values, its truth values, if you draw its truth value, if you construct its truth value, all are true. If all are true, then you can say this compound proposition is a tautology. Right? Munna, clear?
Yes, sir.
This
Sir,
is a
can you
compound
explain it
proposition.
again, sir, please?
Sir, repeat again.
Okay,
Sir, can you repeat again,
Farhan.
sir?
Yeah. Asia. This is a compound proposition. Compound proposition means not a single proposition. If more than one proposition, that is called compound proposition. So this is a compound proposition, okay? Because P disjunction, negation, there are something like this. So if more than one, that is called compound. So a compound proposition that is always true. If you draw its truth value, if you construct its truth value, you will get all are TTT, all are true, right? All are true, then you can say this compound
It's a
proposition is a
topology.
tautology. Yes.
Sir, in
Yes,
the
sir.
As
last
for
line,
example, হ্যাঁ শাহিন,
স্যার লাস্ট লাইনে সবগুলো মানে ট্রু হইলে দেন টোটালজি।
yes, if all are true, that is called tautology.
ওকে স্যার।
Okay.
ইয়েস।
If
Okay,
all
sir.
are false, if all are false, then contradiction. If mixture, if true, false, or something like this, then contingency, something like this, right? There are three things here. If all are true, that is called tautology. If all are false, then contradiction. If true, false, I mean mixture, combination of true and false, that is called contingency. You can check, that is given in your lecture, page number 4. In lectures is foundation and logics. You can check in their page number 4. Okay. You can download the lecture. Okay. You can download
Yes, sir.
the lecture. That is all are given, right? So just try to understand here.
Yes, sir.
So if you draw the truth table, so what will be the truth table? P, Q, then another P conjunction Q, right?
কনজাংশন কি?
After finding P conjunction Q, then you have to find out its negation, right?
নেগেশন।
Negation P conjunction Q. After
Q.
finding this, then you can make this compound total P disjunction with this.
Yes.
Okay. So we know that is TT, FF, TF. So P conjunction Q. So what is the definition of conjunction?
Sir,
P conjunction
when sir two proposition are true, then it will be true. Otherwise
true,
false.
otherwise false. Very good. So only this one is T, rest of are false, right?
Yes, sir.
Can you hear me clearly?
Yes,
Or
sir.
it's
Yes, sir.
network problem?
Yes, sir.
Okay. Now negation of this conjunction, this is opposite just. So here F, T, T, T. That's very easy, right? Now coming to the disjunction. Disjunction between this line with P. This line with P, right? This first column and fourth column. So what is the disjunction definition? If both are false, otherwise
False, then
true,
it
right?
will be. Yes, sir.
Yes, sir.
So here TT, not both are false, so definitely T, right?
True. Yes.
So all, that is otherwise condition, right?
All are true.
Now
Totally.
check, dear student, to conclude you have to check whether all are true or not. If all
true,
are
sir.
true, then you can
Then
say
it's
yes,
tautology.
these compound propositions is a tautology.
Yes, sir.
This compound proposition is a tautology. Compound proposition. This compound proposition is a tautology. Is it clear? MD Ashik? Asadujaman Ashik?
Yes, sir.
Okay. So this is a compound proposition. You can say this is a tautology. Is it easy?
Yes, sir.
Yes, sir.
Asia, can you help us? What is tautology?
Sir, tautology means when all are the compound propositions always truth value, That term that is called tautology.
Very good, right? So if all are true, these values are true, no matter what about the other values, other compound proposition. This is also compound proposition. This is also compound proposition, right? So forget
Yes, sir.
about this. That's why written in definition, no matter what the other values, just this compound, this resultant compound proposition you have to check. You have to determine whether they are same, I mean T, all are T or not. If T, then you can say tautology. If this is a false, then you can say, if all are false, then you can say
It's
contradiction.
not total.
Contradiction. It's called contradiction. Contradiction means if all are false, all are FFF. We are going to solve some math. First, we have to finish our definition. Then we will go through, okay? So do you understand? If you do not understand, please raise the question. Without hesitation, dear student, please raise your question.
Sir, last column to sir, please repeat again. All are true is how is possible?
Okay, so how is possible? That's a good question. I think after drawing this column, Asia, this column and this column, I think you have no question about this, right?
Yes, sir.
Yes, sir.
Okay, now coming here, Rikta, look at the board. Here, this compound proposition, this is a relation between P and this. So P means this column, right? This
Yes, sir.
column and this fourth column, right, Rikta?
Yes, sir.
So you need to make relation, you need to develop relation between these two columns, first column and fourth column. First column and fourth column. So what is the relation? Relation here, disjunction,
Disjunction.
right, Rikta?
Yes, sir.
This is a disjunction. So according to the definition of disjunction, we know if both are false, then false, otherwise true, right, Rikta?
Yes, sir.
So here T and F. So if both are false,
No, sir.
no. So it satisfies the otherwise condition. Disjunction, otherwise condition, right, Rikta?
Yes, sir.
So since not both are false, I mean, so it's T, right?
Yes, sir.
Now T and T, if both are false, this is definitely
No,
not.
sir.
So that's why T. F and T, both are false. Your answer is no. That's
No,
why
sir.
it's T. F and T, both are not false. So that's why T. So that's why we can conclude, since we will get this one, that's why we can conclude, yes, this compound proposition, this
So now it's
compound
clear, sir.
proposition is a tautology. Okay,
Thank you, sir.
welcome. Do you have any other question?
No, sir.
Okay, so we can solve a contradiction math.
Yes, sir.
We can solve a math related to contradiction. So P conjunction Q conjunction negation P disjunction Q, right? So we have to check whether this one is a contradiction or not.
Yes, sir.
So what is the question? Our question is, we have to check, we have to verify this compound proposition is a contradiction or not. We have to verify. Question, if you check the lecture, verify this is a contradiction.
Not.
contradiction. Okay, contradiction. Verify this is a contradiction or tautology or contingency, right? So what is the contradiction definition? As like opposite of tautology, as tautology all are T, all are true, but in contradiction all
All are
will be
false.
false. F, F, all will be F, I mean false. Then you can say yes, this is a contradiction. So now check PQ, we have to draw this, then disjunction. Would you please try? Would you please try yourself? Another
Okay, sir.
column, you need to draw P disjunction Q, then negation of this P disjunction Q, and then conjunction. So already we have done. Would you please try? Have you done, Sabrina? Lubna Akhtar, have you done it? Lubna left the meeting. Shaheen Hussain, have you finished?
No, sir, I'm doing so. Sir, 2 more minutes, please.
Okay, okay. Shaheen. Dear student, do you have any claim regarding to class? If you have any problem regarding to class, please, you can inform me, okay?
So is it all or false?
Definitely it will be false. If you will not
Sir,
get false, so how can you show that
sir,
is contradiction? Yes, Sahin.
sir, all are false.
All or false, sir?
Very good. Yeah, false. Because our definition was contradiction. You have to show the contradiction, right?
Hmm.
Yes, sir.
Yes, sir.
Yeah. So if you get all are false, definitely you are okay. You are right.
Yes, sir.
Yes, sir. All are false.
Very good, Rikta.
I am also done, sir.
Very good, Habib. Now we can check. This is a disjunction, right? So disjunction
Yes, sir.
between P and Q. This one is only false. Rest of are T, right?
Yes, sir.
Yes, sir.
Yes, sir.
Now negation of this disjunction, just opposite F.
Opposite. True.
Done. Then here conjunction. Conjunction between this column and
And this
conjunction. I
column.
mean this column
Conjunction.
and this, right?
Third and fifth.
You have to make relation third and fifth number column. So what
Yes,
is
sir.
the conjunction? So conjunction, if both are true, then you can say
It will be
true.
true.
Is true.
Rest of are false, right? So there is nothing, both are
Yes,
true,
sir.
right? So definitely
Yes, sir.
otherwise condition satisfied. So all are F,
Yes, sir.
okay? So you can say, yes, since all are F, all are false, so that is, this compound proposition is a contradiction, right?
Yes, sir.
And what about the contingency? Contingency, if it is mixture, right? You can check.
True and false
You
mix.
can check. True and false mix. Already we have solved for previous math. You can set as an example, right? If true false mix, you can say yes, this is a contingency. Okay.
Yes, sir.
So last definition, that is the equivalence proposition. How can you say two propositions are equivalent? Dear student, that is given in page number 5. That is given in page number 5, logical equivalence definition. So try to understand. Logical equivalence relation you have to develop, you have to derive between two compound propositions, right? You have to develop this between two compound propositions. Here, all these we have derived between two propositions. These compound propositions, we have constructed these compound propositions between two propositions, individual simple propositions, right?
Yes, sir.
But to determine logically equivalence or not, you need two compound proposition. Like this is a compound proposition, you need to develop another proposition, right? And that will be given, right?
Yes, sir.
So two compound propositions are said to be logically equivalent. Try to understand the definition. Two compound proposition, not a single proposition. Compound proposition. Focus on. You can note compound proposition. Two compound propositions are said to be logically equivalent if they have the same truth value, identical truth value. Do you understand?
Can you repeat the definition?
Identical. Two compound propositions. Two compound propositions are said to be logically equivalent if they have the identical truth values. Identical truth values. Is it clear?
Sir, what is identical truth value?
Okay, identical. I will explain when
Okay.
I'm going to solve. That time I explain what is identical, why I am using this word identical, right? Okay, Sahin. So wait 1 minute.
Okay, sir.
Okay. As for example, if you said example, as for example, that is given in page number 5. As for example, show that you can write, show that P implication Q and negation disjunction Q are logically equivalent. Are logically equivalent. So this is a compound proposition. This is one proposition,
Yes.
compound proposition. This is another compound proposition. We have considered a simple problem for our simplicity. Huh? This is a
Yes,
compound
sir.
proposition, one question. This is another compound proposition. So these two we have to show, we have to determine whether these two compound propositions are logically equivalent or not. So how can you check, dear student? Here PQ, P conjunction Q, we have to So negation of P you have to derive, eh? and then coming to the point, these compound propositions, P conjunction Q, negation disjunction Q, right? I think this is enough, right?
Yes, sir.
Instead of forming two table, for this one you have to form one table, for this one you have to do another table. So instead of doing individual table, you can draw in a single table, right? That is easier, I think.
Yes, sir.
Yes, sir.
If you wish, then you can draw two individual tables. This one for one table, up to this you can draw, and again for this one you can draw another table. Okay, so that depends on you. That is not my requirement. You must have to draw individual table. You can show it in single table, right? Okay, dear student. Now coming negation of P. Negation of P just the opposite. So F T T, right? P implication Q. So if P, we know what is the definition. What is the definition? P conditional statement or implication.
When
What is the definition?
When, sir, exactly one
When
is true,
P
then
is when
both are same. When both are same is true.
no, sir. When, sir, T,
no.
sir, T and P হচ্ছে T and Q হচ্ছে F, then it will be conditional.
F. Exactly কিন্তু এটা. If P is true, Q is false. That
Yes,
time
sir.
false. Rest of are true, right?
Yes, sir.
Am I right?
Yes, sir.
Fairuz?
Yes, sir.
Am I right?
Yes, sir.
So here P and Q. So P and Q, T, not. So this is T, right?
So second row.
T, F, that is F only. Okay? Rest of
Yes,
are
sir.
true. Okay? Not to marker different name. ফাতেমা এই লাল মার্কার গুলো একটা দাও তো। So you can draw.
Sir, can you conditional statement explain again? I have just confusion.
Okay, conditional statement, I mean implication. If P is true, Q is false, then false, right? Do you understand?
Yes, sir.
If P is true, Q is false, then false. So it satisfies P is true, Q is false, then it satisfies this implication condition. So Munna, according to the definition, according to the implication or conditional statement, we will get this one only. We will get this one, right?
Yes,
According to the and otherwise, rest of are otherwise. Okay.
Yes, sir.
Now coming here, you need to make the disjunction relation between negation of P and Q, right? So negation of P and Q. You have to, dear student, you have to consider as this one is first one anyway. So here disjunction when both are false between this and this one, right?
Yes, sir.
So when both are false, then false. When both are false, according to, you can write down here false.
Yes, sir, false.
Am I right?
Second one is also only false.
Rest of,
Yes, sir. Rest of all
True.
false. Yeah, true.
True. Now Mr. Sahin coming, why we are telling identical? Identical means if you deal, maybe some of the students are very those are expert. We have maintained this sequence by considering PQ, TT, FF, TF, TF, right? We have considered only for our simplicity, nothing else. Do you understand?
Yes, sir.
But some of students, they will maybe change. Maybe they have written TF or something like this. Maybe F first, this F first. Maybe you can change it. Definitely you will get same this. You understand? Sahin?
Yes, sir.
So maybe some of student you may check here. Maybe I am writing here T, you may write here F. Here maybe you can change, interchange, something like this. Maybe you can write instead of T, you can write here F. So you can write here T, right? So individual, definitely it will change something like this. This T will. You understand?
Yes, sir.
So if you are drawing this, so definitely it will be different. Maybe in
Yes,
some cases you will get the different result, right?
yes, sir.
So it does not matter. If you consider here TT, if you draw the relation, if you drawing this, so this compound proposition and this compound proposition, if first case are T, definitely it will be also T, right? Right, sign?
Yes, sir.
So that's why we are telling identical. Identical. Huh?
Okay, okay, sir.
So
Got it.
if you change here FT, and definitely it will also change, right?
Yes, yes, sir.
So that's why definitely that's why we are calling it's identical. This TT, FF, TT, something like this. With matching everything, each and every element is matched, right?
Yes, sir. Good, sir.
So that's why we are calling identical truth values. So definitely they have the same truth value, right? And we can say yes, these compound propositions are logically equivalent because they are same, right? Logically equivalent. I mean, in each and every side that is equal. These two propositions are equal propositions. Is it clear or not?
Yes, sir. Yes, sir.
Yes, sir.
Now, can you check your messenger or that is given in your Google Classroom? যেটা আমরা বলছিলাম যে we are going to solve some math. So which one we are going to solve? Would you please tell me the question number? কেউ দেখেছেন? Did you check? Any student check any math? There are several maths are given.
Yes, sir. 9, 10, 14, 15.
So which one, Rikta? Which one I am going to solve now? একটা বলেন।
Sir, 9 number, sir. Conditional statement.
Okay, 9 number. This is a tautology. So 9 number which one? A, B, C, D, which one? Rikta, I think 9 number are very easy, man. So which one, Rikta?
Sir, F number.
F.
Yes, sir.
F number, F.
Yes, sir. Last number. F.
Okay, last number. So 9, F. So we have to show is a tautology, right?
Yes, sir.
Is a tautology. Okay. So P, Q, then negation of Q, right? We have to draw negation of Q, then P implication Q, then negation of P, then result, right? Then result. Is it done? Is it done?
Yes, sir.
Yes, sir.
So you can try at first. We can wait for 2 minutes. Okay, Rikta?
Okay, sir.
Okay, we can wait maybe all of you. I think all of you are able to solve this. Shodi, please try. Mr. Ashik,
Sir, done.
can you solve this? Sahin, have you finished?
Yes, sir. All are true. So it will be tautology.
Very good. What about the other student? Lubna, Sabrina, Farhan, Habib, where are you today?
Yes, sir.
Yes, sir, I'm doing it, sir.
Okay. Rahatil, are you present?
Yes, sir.
Have you finished your math, Rahatil?
No, sir.
Try it.
Okay, sir.
So negation of Q, just opposite. P implication Q, P implication Q. This one is false. Rest of are true, right?
Yes, sir.
Yes, sir.
Now negation, its opposite.
Yes, sir. All are true.
F, T, F, F. Now it's we have to make relation with this, right? This one to this one, okay? So this is first, right? Negation of Q. So implication. So this one F F F, T F, T T, F F T. I think all violate this condition, right?
Yes, sir.
It maintain the it satisfy only the otherwise condition. That means T. Okay,
All are T,
Riksha?
sir.
All are
Yes,
T.
sir.
So now we can check whether all are T or not. This is a tautology or not. Now
So
from
this is a
equivalence
tautology, sir.
relation. Definitely tautology, because check your question. Check the question. We have to show this is a tautology or not. So can you ask? We can solve a math that from equivalence. Our time is short. Would you please tell me the question? Which one we are going to solve? Equivalence relation, logical equivalent. Can you try 22 number if you have no question, because our time is short?
Sir, আজকে আমরা ট্রাই করি না বললে স্যার নেক্সট ক্লাসে বলে।
Okay, at least we can start, right?
Yes, sir.
So at least we can start. এতে বেশি সময় লাগে না, 2 or 3 minutes. So 22 number we are going to solve. Okay. Can you see the board clearly? Weather
Yes,
is
sir, we can see
too
it.
bad, too bad. It's very, very cloudy. In any time, it will rain in my area. 22 numbers show that P implication Q conjunction P R and P implication Q disjunction R are logically equivalent. Are logically equivalent. We can at least start. Okay, Sahin?
Yes, sir.
Here P, there are three propositions, right? P, Q, and R. Okay.
Sir.
Then, any question?
No, sir.
Okay, Mehdi. Sure. P conditional Q, right?
Q.
P conditional
P
Q,
conditional R.
P conditional R. Then you can make this, right?
Q.
Q disjunction R.
Yes, sir.
So better we can show in a single, yeah, okay? No need to draw different tables. So you can make this. P or which one? You can draw this one, right? As you read, there is no boundary condition, okay? Then you can make this one. P conjunction P implication R we have done. Then this next one P Q R. So dear student, only for our simplicity also you should use this technique because there are three propositions. So three propositions. First proposition, when you draw first proposition, oh half of this true false half,
Yes, sir.
always consider as a half, right? That will be better. So first half are true, you can consider first half are true. So first half means there will be 8, I mean 4. So T, 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 T. Rest of 4 are F. Do you understand? Do you understand or not?
Yes, sir.
First half, again, it's first half. First half means what? 4. So 4 half what? 2, right? So T, T, F, F. Do you understand? T, T, F, F. Is it clear? I mean half of true, half of false. Do you understand or not?
Yes, sir.
Yes, sir, understood.
Now it's half. What is the half? 2 half. What is half? I mean 1. I mean TF, 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 something like this. Is it clear or not? You can proceed
Yes,
this
Yes,
sir.
sir, clear.
because if you maintain this sequence, you can draw for 1000 proposition, right? It will take time, but you can draw without making any mistakes, right? Do you understand? So please, you should maintain this one. So TF, TF. Now I think rest of you can do it. Huh? I think rest of you can do it. And best of luck. That's all for today. Okay.
Okay, sir.
Thank you, sir.
Sir, I have
Okay,
missed my
okay,
attendance today, sir.
Lavit,
Yes, sir, I have missed my attendance today, sir.